Hello, I'm Dr. David Kordowitz, and welcome to Programming. Today we're going to be talking about conditional expressions. Conditional expressions allow you to compare two values and use that to make decisions within your program. Let's begin. We remember back when we were talking about flowcharts that we had these decision points that we could ask a question and then change the path of execution based on the answer. So in this case, we say, is n greater than 5? If yes, go down. If no, go right. So programming languages allow us to code this type of question very simply so that we can path our execution based on the values we see. So how do we do this? Well, let's start with conditional expression. The first symbol is the double equal sign. That means that the two values are equal to each other, so is equal to. So if I say A double equals B, that is going to tell me that it's true when A and B have the same value, but it's going to be false at all other times. It's important to note that the single equal sign is always the assignment operator and the double equal sign is always the comparison. This is a very, very common error that people make when they're first learning C, C++ type languages. The next one is greater than, which will test to see if a number is greater than another number. So A is greater than B. That said, with the greater than, it must be larger to be true. So what that means is if the two are the same, this will be false. We then have less than, which is the exact opposite. The next one we have is greater than or equal to. In the case of greater than or equal to, the equal case will give you true. So this gives you the ability to customize your results based on whether it's equal to or not equal to. The next one we have is the exclamation point equal sign, and that is not equal to. So that's basically if you want to take two numbers and make sure they're different. This is different in MATLAB. However, the concept is exactly the same. The next two that we have are the and or operators. The and operator is only true when both conditions on both sides of it are true. So you can use the and operator and the or operator to create much more complicated logical expressions, or requires that only one of the expressions is true, but it will also be true when both are. So it's important to also note that we are using the double ampersand and the double pipe character. The pipe character can be found above the backslash on most computers. The single ampersand and single pipe are what we call bitwise operations, and that is beyond the scope of this course. It's also important to note that the single exclamation point is the logical not, which will invert the true-false case of a given conditional. This can be really useful if you want to check if something is sort of not the same, or if something is not greater than, which would mean less than or equal to, but it can be handy when you're writing programs sometimes to make the conditions flow a little easier. So let's take a look back at our is n greater than 5. So how will we implement this? Well, in most modern programming languages, we have a command called if. So if allows us to compare two things and do something if it's true. So the if command makes us capable of doing very, very simple decisions very, very easily. So the syntax of it in C is if, and then you put your logical expression, and then you have some curly braces. What's in the curly braces will occur if the logical expression computes to true. So if we would write this one out, it would come to if n is greater than 5. In the case that n is greater than 5, we're going to follow the yes. However, what happens if we have no? What if n is not equal or not greater than 5? Well, it turns out that we have no case for this. So we have nothing. If the answer is no, the program just doesn't do anything. So what we can use is we can use the else command. So the else command allows us to do something in the case that this is false, or in the case that none of the if statements are true. I'll show you how to do more if statements in a second. The context for this is just else and some curly braces. So when you put the else, this will run anytime the if isn't true. However, it's important to note that the else needs to be immediately following the if statement. If it is not, it won't know how to handle it. Notice there are no semicolons at the ends of the curly braces. If you do put one there, then you have terminated the if or the else, and it won't know what to do with it. So don't do it. So what happens if we want to get a little more complicated? So let's say now that we want to check more than one status. So let's say we want to check if, something is less than 5, something is greater than 5, or something is equal to 5. So if we think about it, the simple if statement won't work here. The simple if statement will simply compute whether or not it's one of these things. So we can do a few things. One thing we can do is multiple if statements. Another is what we call if, else if, and else. So let's take a look at how that works. So we can start out with an if statement just as we did before. And this if statement will basically test for one of the conditions. We can then combine the else and another if to basically allow the directive to continue down. So this allows you to waterfall through the else ifs, and then if nothing is true, you do the else. Now it's important to note, and you want to put the most restrictive item first. And the reason for this is that the first else if or if that's true is the one that's going to run. So in other words, if you say n is not equal to 5 is the first one in this case, what had happened is if the less than or the greater than case will fall forward. Now, if it's equal to it, it's going to stop. So when you get a little more complicated, however, sometimes there are conditions where what your input is may match multiple sets of conditions. So you want that first condition to catch correctly for what you want to happen in that case. So you go from most restrictive to least restrictive, because else is basically the pool of everything that doesn't meet any of them. So let's take a look at how we would do this. So we can start here with else n, or if n is greater than 5. So that'll get us to the tier on the right, and not the other ones. However, we're going to cascade down if n is not greater than 5, and we're going to say else if n equals 5. Well, n equals 5 will take us down towards the bottom of the flowchart. So now we've checked if it's greater than or equal to. The only other case we have is less than, because the number is either going to be bigger than, equal to, or smaller. So less than can then be handled in the else case. If you want to be pedantic about it, you can make another else if and say else if n less than 5 and then put an else in there or not put an else in there. In this case, because there's only 3 possible states, you might as well just go ahead and use else, because it'll be more confusing later on. You can put a comment in your code with a double slash to remind yourself of why you did it the way you did. Okay, so if else if structures though can get really, really large really, really fast. For example, if you're trying to put together something that has 10 outlets, that's going to get a lot of code going for not a lot of power. Most modern languages, however, give us a good solution to this, and that is called switch. So what a switch statement does is a switch statement allows us to run through different cases without having to have an if statement for each one. Now it's important to note in C and C++, the value going into the switch, or n in this case, is simply got to be either an integer or a character. It can't be anything else because that gets way too complicated. In MATLAB, however, it can be whatever you want it to be. We'll get to that when we get in MATLAB, how to use it there. But for now, let's assume that it can only be a character or an integer. And so what we do is then we put case lines. And what the case line is it's basically a bookmark in the code. So we look at the n and we say, well, is n equal to 1? If n is equal to 1, we go to case 1. You can stack cases also if you really need to, where you can say case 1 colon, case 2 colon, case 3 colon. So if you have groups that you want to go through the same code for, you can do it that way. It's important to note that anything beyond the colon here will begin to execute. You need to put a break statement at the end of your switch, of each case for your switch. Otherwise, when it completes one case, it's just going to continue on to the next and the next and the next until it gets to the bottom of the case, the switch statement. These breaks are relatively important. It's also important to note that because of scope rules, if you wish to declare any variables within a case, you need to put the case after the colon in curly braces to create a scope that ends before you get to the bottom of the switch statement. The last thing to mention in a switch statement is the default case. The default case is effectively our else. So the default case is where you land if you don't meet any of the switch criteria. So basically, if you don't make any of the cases, it'll throw you into default. So it's really important to know when you do this that it's sort of basically an if, else if type structure, but you don't have to build everything on your own because the programming language is doing it for you. Okay, so let's take an example here using the Arduino. For today's example, we're going to look at using the push buttons to play a sound. We're going to be using the if statement here and an else if eventually to be able to play audio depending on whether buttons are pressed. So the first thing we're going to do is we're going to define the button pins. And we know from previously that on the circuit playground, define, button A is going to be on 4 and button B is going to be on 5. So we're going to go ahead and set those up, and we're going to use the built-in pull-it-down resistor to prevent the buttons from doing things that we don't want them to. So let's start with pin mode, the A, and we're going to set it as an input pull down. And what that's going to do is that's going to connect a resistor to ground so that the button will be required to be pressed for it to give you a value. Otherwise, the button just is not connected, and this can lead to small errors which will lead to the button thinking it's been pressed. Again, we're going to do this for button B, and we're going to use input pull down. By doing this now, the buttons will not be pressed when we are first powered up, and if you push the physical button, it will. So what we're going to do in the loop is we're going to then again check the buttons and see if they're pressed. So let's say Boolean. We're going to say Boolean A and B. You can use the comma if you want to declare multiple of the same type in the same line. So then we're going to say A equals digital read, and then that's going to be BA. B equals digital read BB. Okay, so this is going to set everything up, so now we know what A and B are. So what we can do is we can say, well, if A, so basically if A is true, so if the button is pressed, what do we want to do? Well, we're going to use the tone command, which is part of Arduino C, and the tone command allows us to play a tone. So let's take a look at the documentation for this command. The tone command is going to basically take in the pin where the speaker is located, and if we look at the documentation for a Circuit Playground Express, it's located on pin A0. In this case, we do need the A. In addition, it needs the frequency of the tone, and it optionally takes the duration of the tone. And the duration of the tone basically is how long do we want it on in milliseconds. So let's go back to our code and set this up. So in my code, I'm going to say that I want a tone, and I want to play it on A0. And we want it to be, let's say, 440 hertz, which is an A for those of you who are into music. So now we want to put a duration. So let's say 100 milliseconds. Now, if I run this code as it is, it's going to be getting back to this tone command before it has a chance to play the tone, which will then overwrite, and you're going to end up with some weird behavior. So the best thing you can do here is add a delay. And we can add a delay of 100 milliseconds. And what that's going to do is that's going to guarantee that the tone has enough time to play before the loop can come around again. So let's go ahead and write this to our board. I'm going to push this button here, and it's going to ask me to save it. And it's going to compile and then push it out to the board. If we give it a second. All right, so it is on the board now. So if I take the board and I press the A button, you can hear it make some sound. So what happens now is that it makes the tone if I press A. Now if I press the B button, nothing happens. So what do I need to do? Well, I need to add in a case for if the B is pressed. So I can say else if B, and let's say that we're going to play a tone at a different pitch. Tone, and we're going to say A0, and we're going to say, instead of 440, let's do 880, and we're going to do it for 100 milliseconds. And we're going to say delay 100 again. Let's now write this to hardware. So we run this. And okay, so it's on the board. So now if I push the A button again, I get the same tone. Now if I press the B button, I should get a different one. Okay, so that else if is checking for if A or B. So now let's add a slightly less restrictive case. I'm going to say else if A and B. And so what that's going to check for is that's going to check for the case of A and B. However, if you notice now, A and B, well, if A is pressed, we're going to catch A. If B is pressed, we're going to catch B. So really, this needs to be the first case. So let's cut this and move it up top. Because if A and B are pressed, you're going to end up with the response from A. So let's move it up here as an if statement. We're going to change our A to an else if. And we're going to say if A and B, let's go ahead and do a tone. A0, and let's do something like 10 kilohertz. I'm going to play that for 100. And let's make the delay here 150. Okay, so now we have if A and B are true, so if both buttons are pressed, you're going to play this sound. If A is pressed, you're going to play this one, and if B is pressed, you're going to play that one. All right. So now I have an extra semicolon, so let me get rid of that. So let's run this. And it's going to take a second to compile and go to hardware. So now if I push the A button, if I press the B button, if I press both buttons, so it's a much higher frequency sound, and it's pulsing because the length of the delay is longer than the length of the tone. All right, so let's say now we want to have it do something in the default case. So we want to have it do something when nothing is pressed. So we can say else, and now whatever we're going to do in here, we can do. So let's say, for example, digital write 13. 13 is the LED pin. So we then have to add a pin mode line, and we're going to say LED is going to be 13, and we're just going to say output. So now we're going to write this to hardware. So we're going to click the write button to compile and write to hardware. It's complaining that there's an issue. Okay, so digital write 13, and we want to put, we're going to make it high. And then we're going to also go ahead at the top and shut the light off. So we're going to say digital write and we're going to say 13, and we're going to say low. Now we're also going to add a delay in here of about 100 milliseconds after digital write in order to allow some time for the light to be on. So actually, let's say about 50 milliseconds. So we're going to try again. Let's write it to hardware. And I made a typo, so we'll fix that. We all make typos sometimes when writing code. So we're going to compile it and send it out to hardware. It is now completed compilation and is on the hardware. So let's switch over to the hardware real quick. Here's my board. If you notice, the red light is lit over here, and that's because none of the buttons are pressed. Let's say I come in here and I'm going to press the A button. That light should shut off. And if I release it, it comes back on. If I press the B button, it's hard to see, but the light goes out. And if I press both buttons, the light goes out while you're pressing them. So basically, in a nutshell, what's happening here is the if statement and the else if statements and the else statements are working together to test whether something is happening and use the values that I'm finding to determine whether or not the program should execute at different pitches and different ways. Thank you for your time today, and see you next time.